Hey guys, so in this video I want to cover two more graphs that that are used for one variable data, and that would be the dot plot and the stem plot graphs. Okay, so both graphs, like I mentioned before, they're used for one variable data, numerical data only, and both are used for small data sets. If you have large data sets, they're going to become messy and basically unusable. So for large data sets, it's better to use grouped data, which is steamplot is kind of like a group data, but not exactly. So we'll talk about this a little bit after we're done with these graphs. Okay, so for dot plot, it's very easy. You have the number line, and you're just plotting a dot above each value that you have in your data set. So for example, we have a 0. So we plot a 0 above 0. And then 2, so a dot above 2. 3, a dot above 3. 4, a dot above 4. And then we have 2 again. So we go back to 2 and we plot another dot above 2. 3, and we have another dot above 3. And 4, another dot above 4, and so forth. We're going to continue this. 6, 7, and the 2 again, and the 3, and the 4, and the 6, and the 9, hold on, 6, 7, and we have 1, 8, and 1, 9. Okay, so this is our dot plot. It's completed. Let's talk about stem plot. So here we go. So stem plot is kind of like grouping, okay? So we're going to be grouping data according to like what they have in common. And what you see here with this data is that the last digits, they're all different, right? But some of the first digits are repeating. So for example, we have for 130, we have this value, and I know I have one more right there that starts with 1, 3. So they're going to be grouped together. Then I have numbers that start with 1, 4. So here they are, and I'm going to group them together, these values that starts with 1, 4. Okay, so I'm gonna start actually, I'm gonna start my stem plot graph. So what you do for a stem plot, you're gonna have a stem. For stem, you're gonna put the value that they here that they have in common. So for example, these 3, they start with 1, 3. So I'm gonna put 1, 3 here, and the values that are different, and that would be the 1, the 5, and the 3, that the ending digit, that I'm going to put in the leaf right here. Leaf. Okay, so for the leaf, and I'm going to list those last digits in ascending order. So 1 first, and then 3 is next, and 5 is next. So I have 3 numbers that starts with 1, 3, and 1 ends in 1, the second ends in 3, and the last one ends in 5. Okay, so these values could be recreated. Like if I didn't have the access to that data set anymore, I still know exactly what kind of values I had in the original data set. So that's one of the advantages of a stem and leaf, and actually a dot plot as well, because in the dot plot you still know what kind of data values you had, even though you don't have them in the same order, but that's not important. What important is that all the values are still there. They're not um, uh, disappearing. Okay, so let's do the numbers that start with 1, 4. So I'm gonna put 1, 4 as a stem, and again I have one with a 0, one with a 1, and then I have two 4s. So I'm gonna put 2 of them, 4 and a 4, and then 1, 7. And 1, 8. So I have 1, 2, 3, 4, 5, 6, 7 of those values. 1, 2, 3, 4, 5, 6, 7. Yes. And I'm going to continue in this way. Okay, so now I got the values that start with 1, 5. Circled in green, and I have 1, 2, 3, 4, 5, 6, 7 of them. So again, I'm gonna put the common part here, 1, 5, and the ending digits in the leaf. What's the smallest one? I think the smallest one is 2, and I have 2 of them, right? 2 and 2. Oh, I had a 1. So a 1. And then 3, 6, a 6, and a 9, and another 9. Okay, so 3, 6, 9, and 9. I have 1, 2, 3, 4, 5, 6, 7 of them. Yeah, and I'm gonna continue that for 16 and 17. And you can pause here and try to fill it out, finish filling it out by yourself. All right, so this is what I got. We had 5 values left, and 2 of them started with 1, 6, and 3 of them started with 1, 7. Okay, so this is a complete stem and leaf plot. Again, we can restore any data values that were there. In fact, our next exercise, we're going to do that. Yeah, it's easy. We're going to talk about why we're doing it in the next video, or one of the next videos. So now on to the next example. The next example is asking me to find the original data from the stem plot. So I know I have 3 values that start with 6, 4. So it's 6, 4, and the first one ends with a 1, so it's 641. The next one ends with a 6, so it's 646, and the next one ends in 8, so 648. So that's what I have for the values that start with 6, 4. Then on to the values that start with 6, 5. So I have 6, 5, 1, 6, 5, 3, and 6, 5, 9. So those are the values, 3 values that start with 6, 5, and then I have 2 values, 2, that start with 6, 6. So those would be 6, 6, 1 and 6, 6, 8. All right, so this is the original data set. Again, not in the same order as it was, but a lot of times we have to line it up from smallest to largest anyway. So here it is. One thing that I wanted to mention about those graphs, the stem and leaf graph is suitable for numerical or quantitative data only. More, it's only suitable for discrete data, because if we had a lot of decimals, it would not work. I guess if we had the data like 2.3, 2.5, 4.6, we could make the decimal, the whole part a stem and the decimal part is a leaf, but it's only possible when they're all rounded to the same number of decimal places, and that would be discrete data set. Okay, with dot plot too, it works best for discrete data. I mean, it is possible to plot continuous data set over the number line, okay, because we have basically all of the numbers represented here on the number line. But I guess they would be like bunching up together too much, where this graph would be not very usable for our purposes. Okay, so it's possible, but it is not used like that. I think probably one of the graphs that you saw before in one of the Desmos activities, when those dots, they were not stacked up like that, but they were all put on the same number line, and where they had more than where they would bunch up, they would indicate that with a color, the color would be different. It would be darker where you had a lot of data values. So it could be done like that, but mostly it's used for discrete data set. That's what I wanted to mention.